Good day, students! In this video, you will learn all about circle, how it is defined. You can also determine the standard form of the equation of a circle, and lastly, how to graph a circle. First, let's have a circle. Circle is defined as a set of all points P, x, y in a plane with a constant distance r, which is the radius, from a fixed point called the center, denoted as C, h, k. Thus, all points on the circle will have an equal distance r from its center. To elaborate that, let's go back to the given circle. The center, denoted as C, h, k, represents any location in the Cartesian plane. Then let's proceed to point P, x, y. This is a point on the circle. Now, we have a distance from the fixed point, center, going to point P, which will be called as r, or its radius. Now, circle is defined as a set of points with a common distance from its center. That means we can have a point here, 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 and here. Then if we are going to find its distance from the center, we will always have a common value. From this, it will have the same distance with this. So, in order for us to have the standard form of the equation of a circle, we will do a deriving of formula. Let's go back to the circle. As you can see, we are finding the distance between the center going to a point. So, we will find the distance between 2 points. So the formula will be the distance is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And this would be our distance formula. So from the distance formula, we will let x sub 2 as our point P, which is x, y, and we will let x sub 1 as C, or the fixed point, h, k. So, instead of writing D, we will represent that as r, since we are referring to the radius, which is its distance. So, r is equal to the square root of our x sub 2 is x minus x sub 1, which is h, squared plus y sub 2, that is y, and y sub 1, that is k, squared. So with this, we are saying that we are looking the distance between point C to P. Now, we will square the both sides in order for us to eliminate the square root sign. So that will be, the square will be cancelled out, and that would be r squared is equal to x minus h squared plus y minus k squared. And then next, through symmetric property, we can also rewrite this as x minus h squared plus y minus k squared is equal to r squared. And that would be our standard form of the equation with center as hk. Please note that if the center hk is at any point, then the equation will be x minus h squared plus y minus k squared is equal to r squared, where r is the radius. This one is similar to what we have derived earlier. The question is, what if the center HK is at the origin? So instead of having HK, we will now have 0, 0. Then the equation will be x squared plus y squared is equal to r squared, where r is the radius. So you may be asking, what happened to h and k? So since our center is at the origin, therefore h and k will be written as 0. So if we were going to simplify that, we can just write the standard form as x squared plus y squared is equal to r squared. Since general form is also needed, we will gonna convert the standard form to the general form of the equation of a circle. So we will start with the standard form, and that is x minus h squared plus y minus k squared is equal to r squared. First thing to do is to expand the squared terms, which are x minus h squared and y minus k squared. This will become x minus h multiplied by x minus h plus y minus k multiplied by y minus k is equal to r squared. Next, we will multiply with the use of FOIL method. So, x multiplied by x, that is x squared. Negative h multiplied by x, that is negative hx. Then, negative h multiplied by x, that is negative hx. Then negative h multiplied by negative h, that is positive h squared. Then proceed to the other one. We have y multiplied by y, that is y squared. Negative k multiplied by y, negative ky. Then negative k multiplied by y. We have negative ky. Then negative k multiplied by negative k, that will be positive k squared, is equal to r squared. Next, we will combine the similar terms, which are the one written in hx and ky. So this will be x squared minus 2hx plus h squared plus y squared minus 2ky plus k squared is equal to r squared. Next, we will rewrite this in the standard manner. That is x squared plus y squared minus 2hx minus 2ky plus h squared plus k squared is equal to r squared. Now, we will equate that to 0. To do that, we will apply addition property of equality by adding negative r squared to both sides of the equation. So this will become x squared plus y squared minus 2hx minus 2ky plus h squared plus k squared minus r squared is equal to 0, because r squared minus r squared will be 0. And now, there are terms to be put in one grouping symbol because they will represent one variable. So this will be x squared plus y squared plus the quantity of negative 2h multiplied by x plus the quantity of negative 2k multiplied by y plus the quantity of h squared plus k squared minus r squared is equal to 0. Now, we will let v is equal to negative 2h. We will let e is equal to negative 2k, and we will let f is equal to h squared plus k squared minus r squared. And therefore, we will have
x squared plus y squared plus bx plus ey plus f is equal to 0.
And this will be our general form. Now, if we will be dealing with the standard form having its center at the origin, so we will just have x squared plus y squared is equal to r squared. So in order for us to have the general form in this, we will just equate this one to 0. To do that, we will add negative r squared to both sides of the equation, and then we will gonna rewrite that. So that would be x squared plus y squared minus r squared is equal to 0. Because r squared minus r squared is equal to 0. And that is our standard form having its center at the origin.